Okay, this is my response to Neil deGrasse Tyson's video. Is our universe inside a black hole? Now, obviously, that sounds crazy, right? And I've only watched like less than a minute of this video, but I was like, I need to respond. And I'm responding from a layman's point of view. I don't have like a PhD in astrophysics or mathematics or anything like that. Like, I'm GCSE level education, right? But I have read A Brief History of Time by Stephen Hawking. I used to actually carry it around with me everywhere I lived because when you're really stoned, it's one of the best books you can ever read. But okay, let's go back and we'll to the beginning. And I'll give my layman's response, right? Hang on.
Beyond which there's no evidence that our universe might exist inside a black hole? What's up with that? Well,
yeah, like what's up with that? That sounds like almost like a clickbait title or someone's written like a clickbait article because that sounds pretty fucking crazy, right?
let's back up for a moment,
Let's back up.
okay? And put some base information on the table. A black hole is a region of space and time where the strength of gravity is so high.
No, it's not a region of space and time where gravity is so high that it creates whatever, almost a singularity, or he says like where light can't escape. It's a theoretical area of space and time within the model of whatever relativity or something. It's he's saying it is. I'm saying it's theoretical. Why is he not saying it's theoretical? As far as I know, black holes are still theoretical, right?
That light has no path to get out of the object. All paths through space-time curve back in on itself. Normally we think of a hole as a hole in the floor.
Yeah, in the model, right? In the model. Yes.
And you fall through, come out the other.
In the model of space-time, in the theoretical object that is a black hole.
Side, except it's a three-dimensional hole. You can fall in any direction. That edge, beyond which there's no return, we call the event horizon. It's a horizon. The universe.
The theoretical edge of the theoretical object. I don't mean to sound like Sverige just going on about this, but he started out with this as like it's a real thing. Maybe it is, man. It could be. But okay, I don't keep up with like astrophysics, right? But I thought that black holes haven't been proven yet. If they've been proven yet, can someone like link down below where they've been proven beyond doubt?
Has a horizon too. It is a distance beyond which no information can reach us because the universe isn't old enough for light from anything beyond that horizon to have gotten here yet. By the way, the more mass is in a black hole, the bigger the black hole becomes. In fact, if you run the math on it, it's
In a model. It's a mathematical model. A black hole is a mathematical model.
It's linear. So a black hole that's twice as massive as another one will be twice the diameter. 10 times as massive, the event horizon, which is our practical definition of the size of the black hole, will be 10 times as long. There's a cool exercise we do in graduate school. You can say, given the mass of the universe, how big would the black hole be that can...
Okay, this is interesting, right? Now I get where he's going. This is like an interesting thought experiment.
contain this much mass? It's the size of our universe to our horizon. And it's like, wait a minute, could we be one giant black hole? The average density of matter contained within the size of our cosmic horizon matches right on with what you get for a black hole this size. That's intriguing. Maybe it's just a coincidence. What would it mean anyway for us to be inside a black hole? How would that work? Well, it turns out if you run the mathematics of Einstein's general theory of relativity into a black hole, it turns out a whole new space-time opens up on the other side. And you look behind.
I mean, yeah, it's interesting, but like, we're very new to this, right? You know, we've not even had telescopes for that long, you know? And yeah, you can suggest these crazy ideas and stuff, but my problem is like, it's okay to suggest crazy ideas like this, or we all live in a simulation because of simulation theory. That's fine, but if you say something like religious in any way, were you just mocked in a way, like that's stupid, like that's crazy. Like, but it's not crazy to say that the Big Bang Theory is real with what exact proof? And yeah, if someone ascribes to the Big Bang Theory, and you know, I think that the beginning time of the universe has changed many times recently. That's fine. If you believe in any kind of religious or spiritual ideas, you're just insane. What's less insane about those ideas than everything came out of nothing in a single point, or whatever the Big Bang Theory actually is? Like I say, I'm not a astrophysicist.
Behind you and the entire future history of the universe unfolds relative to your time frame. And so the universe you came from basically ends and a whole new universe opens up in front of you. Are we that universe that opened up in front of us? Okay, these are mind-bending questions. Well, there's recent research published that suggests that the contents of our universe has sort of a net rotation to it. Well, that'd be kind of weird. So in this study, it observed several hundred galaxies from the best observing directions you can come up with, which is above and below the plane of our Milky Way. And it noticed a net rotation of spiral galaxies in one direction versus the other. So if you look at
Okay, that's interesting. But how do we get to this? How do we leap to that we're inside a black hole from here?
spiral galaxies, if half of them sort of rotate like that and the other half rotate the opposite way, then they kind of cancel. But if most of them are rotating in the same sense, in the same direction, then that could hint that there's a net angular momentum of the entire universe. So what did they find? That 2/3 of the spiral galaxies measured rotated in the opposite direction as the Milky Way. So 2/3 is not 100%, but it's certainly more than half. So we expect this to just be random. Normally in our lives, we think of something that rotates because some other force set it into motion to do.
Look up there in the corner. He's got a globe. He's not a flat earther.
So. And we look in the universe and everything is rotating, and then you ask, what force is making that happen? Turns out, all of our evidence suggests that when you make a galaxy or a star system or a star or a planet,
Evidence or models? He seems to mix up evidence and models.
there's some gas cloud that started it. If the gas cloud has any motion at all, the tiniest amount, as it collapses, its rotation will speed up. The gas cloud that was large, moving just a little, will move much faster as it gets smaller. And you know this already when you see ice skaters. When an ice skater spins and they want to spin faster, they start with their arms outstretched. And they have a certain rotation speed by virtue of that. As they bring their arms in, this is a phenomenon of physics called...
As a child, I used to go on, the roundabouts, and would spin them up, and then we'd all pull ourselves into the middle, and it would go faster. So he's correct, but is this relevant?
The conservation of angular momentum. If you start out large, slowly rotating, and now you're half the size, you're going to be rotating twice as fast. If you want 1/10 the size, you're going to be rotating 10 times.
Like, this is like all like Newtonian sort of physics, isn't it? Like, which is like still kind of young. Just because it works locally in small things, does it work on the huge scale that they're talking about with the universe? It just seems like a bit of a kind of leap.
As fast. Is that right? mv squared over r, right? This is why everything in the universe has some kind of rotation. Because essentially impossible for any large gas cloud to not have motions within it to begin with. Often they're thermal motions. There's turbulence within the cloud before it sort of collapses to become something solid.
We think. I've got no problem with anything like Neil deGrasse Tyson says, apart from he never sort of says, we think, or like, at the moment, this is what we think is happening. It's always like sort of stated as fact. When, like I say, I'm not a PhD astrophysicist, but it seems that throughout history, the models of the cosmos change considerably every now and again. And it's like, well, we thought it was this, but our new model is a little bit better.
Because of the turbulence within the clouds, there's no reason to think they would align with each other. They're each independent entities, so that when they collapse and the final product is spinning, there's no reason to think that the spin of this object is going to match up with the spin of an...
Okay, so we're still getting to this idea of like we could be in a black hole somehow.
object over here. We have every reason to presume that there's no net...
Black holes, as far as I'm concerned, or as far as I know, still being theoretical, right?
spin direction of the universe or objects within it. So if we find and confirm that there is, we got to go back and ask, how could you get that, given our expectations of randomness? Well, that was linked to the idea that we might be in a black hole. Here's why. There's only two kinds...
It's like, to me, the craziest thing I'd heard before this was the Big Bang Theory, right? This is just like the next level. It's like, how crazy does it need to become, these ideas? If it's completely speculative or something, okay. But it's not kind of being presented like that. It's being presented as like, this is like a reasonable idea. It's about as reasonable in my mind as that Earth is like balanced on a turtle and it turtles all the way down. Or is it tortoises? I can't remember. Turtles or tortoises?
kinds of information you can obtain that are preserved in...
Or was it elephants all the way down? I don't know. In Discworld, it was a turtle, right? I might be getting mixed up. I think maybe it's elephants all the way down. Or we're inside a black hole.
Inside that black hole. The mass, the total mass, and the angular momentum.
I might have missed something. Let's go back a little bit.
That there is, we got to go back and ask, how could you get that, given our expectations of randomness? Well, that was linked to the idea that we might be in a black hole. Here's why. There's only two kinds of information you can obtain.
Okay, but can we like at least prove a black hole first, that there is any black holes? As far as I know, correct me in the comments, we haven't like proven that black holes exist. I might be missing something.
That are preserved inside that black hole. The mass, the total mass, and the angular momentum. Because anything falling in, if it falls in with a swirl, toilet bowl style, that angular momentum continues into the black hole itself. If there's a net angular momentum of the universe, where did it come from? It's not obvious that would come from a Big Bang, which is an explosion in all directions statistically evenly. What could it be? Could we be...
Well, no, like it's not statistically perfectly even, or it wouldn't have clumped the Big Bang thing, right? If it was a Big Bang that was like universally even, like proper style, then it's not going to clump into galaxies and stars, right?
A black hole with a net angular momentum of stuff that spiraled into us. So that's where the black hole connects back to whether the universe is rotating. So I look forward to seeing whether this result is confirmed or falsified. It's an intriguing result.
Like, what I'd like it is you said, like, okay, I've got a crazy idea for you. Buckle the fuck up. Wait for this. This is crazy, right? some scientists think we're in a black hole, but it's not. It's like it's sort of presented like it's not absolutely on the fringes of insanity.
Oh, and the number of galaxies was not very large, just a few hundred, and there are billions of galaxies out there. So,
But yeah, if you believe any of the like ancient spiritual theology ideas about the cosmos, then you're just insane, right?
I'll reserve judgment until I see what others publish on this subject. Anyhow,
That's fair enough. He's reserving judgment, which I respect. I respect Neil deGrasse Tyson for reserving judgment on this. Has he reserved judgment on other things that he states as facts? I don't think so.
that was a what's up with that on whether or not we are living in a black hole. And if we were, what difference does it make? But it's fun to talk about.
Ah, yeah, that's true, mate. Exactly. I'm on board with that. Okay, I take it back. He's saying, like, what difference does it make? And that's exactly the point. So, yeah, I take it back. My criticism of him, like, saying it's a fact, because it kind of doesn't matter, really, to everybody in their everyday life. And he gets that, and I think that's kind of cool that he said that.
Until next time.
And he said it's fun to talk about. Okay. So yeah, in conclusion, like, I'll play the last bit, but in conclusion so far, I'm thinking, this is an insane idea. Most of the ideas about the cosmos are kind of insane, given that we change the models every however long, like 50 years, the accepted models change all the time. There isn't a complete, what do you call it, scientific consensus really about stuff. It's still like a mystery, you know? People are building models and testing the models against observations, and sometimes the observations don't work, so they create shit like black holes and dark matter or whatever. Or they improve the model and it meets more of the observations, right?
Keep looking up.
If you love a good mystery,
Okay, that's the end of it. Thank you for watching.